All right, how's it going today?
Going good.
Cool. So, any questions before we start talking about sockets and networking? You broke it.
I'll talk to you after class.
Okay.
Can we talk about that file that's due, or like the document that is due on Monday, no more?
Yeah.
What are some things you want to specifically see in there?
I would.
Or points you would want to see that's not really stated?
Ideally, I would like to be able to read your document and then be as much of an expert on your project as you are. Right? That's the goal. That's not always doable, but so what project are you working on?
I'm working on like a Dungeons and Dragons, throwing together database.
Okay, so it's a computer game, right?
Essentially, more sort of a database where you can randomize things and
Okay, so for
have access to things.
to help you
All in
play.
one place.
Okay. Yeah, so you've got some code, you've got a database structure, things like that, right? Basically, you want your document to describe your project, right, for somebody who's never heard of what you're doing, to talk about what it is that you're doing, why you're doing it, what the features are, what the advantages of it are, and so on and so forth, and then to talk about your implementation. So if you've got a database of, objects or spells or whatever, right, talk about that and how you're organizing things. And I'm looking for a fair amount of detail, right? In the fall submissions for the SLP, it was like, I'd like to do such and such, it's gonna have this and that and the other thing, right? And it was a pretty high level view. Okay, so I want the details now, right? Now that you've actually done whatever you've done for this. If you've written code, talk about the code, put in flowcharts, pseudocode, things like that. If you've built a circuit, put in a circuit diagram, put in a system diagram, describe what the circuit does and how it works. That level of detail, right? So that somebody could theoretically take your report and come up to speed on what you're doing. If you wanted to work with somebody on this, you wanted someone to partner with, you could hand them this document, they could read it, and now they could converse with you fluently about your project. That might be one way to think about it. So it doesn't have to have specific sections, but make sure it looks like, a technical report.
So if I would have handed it to a random student, they would understand what.
Yeah, exactly.
Okay.
Yeah.
So if your project is primarily a program, do you want us to give the program to you? So now is it okay for you to set like snippets of the code?
You can put in snippets of the code. That's a good idea. If there's, this section does this, you want to talk about that. If you put it up in the cloud somewhere, you can put a link to it. If you don't want it in a shareable link, right, if it's proprietary or something like that, let me know and I might ask you to show me the code offline or something.
Okay.
But
So just show it to you somehow.
yeah. And if you want to put it in the PDF, that's okay with me, right? It might make a huge PDF, but I'm not printing these out, so that's okay. Other questions? Do you want to talk about command line arguments? Okay. So how did it break?
So under, when I went into the run debug settings, my main class wasn't there. So I did new and then went to there and then
It should be there if the project is open and selected.
okay. I deleted it and then it ran it.
So,
Do I go into it from the top file?
so yeah, we're talking about command line arguments for PA4 here. So in your package explorer, make sure you only have one project open, right? So let's say I want to do towers, right? So right click on that, say close unrelated projects. That'll close everything else except the project that you're currently trying to run. And then right click on that in package explorer, right, and do your run debug settings. And it should list your, got it there now? Okay, good. All right, anything else? Cool.
Thank you.
Yeah. All right, so your PA4, make sure that it accepts a command line argument. Okay, that's the way I'm going to test it. So if it doesn't accept a command line argument as the name of the database file, I'm going to have to go in and hack your code. And that's going to cost a few points. So from Eclipse, you want to be able to go over here, click on your configuration, edit, go to command line arguments, and put in program arguments here. And whatever you put in here, when you run your code, wherever your main is, my main's over here in towers. Right? Whatever arguments I put in that window will show up in this array that's called args, right? So whatever you put in for the name of your argument in your main method, right, you can use that to pick up the command line arguments. So if args has anything in it, so you can check args.length, if it's equal to 1, it means there's a command line argument. Just use args bracket 0 as the name of the database file. Right, and that lets it read whatever I specify. All right, so let's talk about networking. We're going to be doing this for the next week probably, and you'll be using this for PA5. So we know how to open files, right, and write to files and read from files, and we've played with pipes. And so there are these things called sockets. And sockets are almost like these kind of virtual files that you can write into and you can read from. Right? So I can open a socket and I can write some stuff into it. And you can also connect to that socket and read from it, and whatever you read will be whatever I've written. Right? So it's a way to allow two things to communicate, and these two things could be different threads, they could be different processes, they could be on different machines, okay, if they're connected through a network. So these sockets are identifiable by a network address and a socket ID, which we call a port number. And this is how our networked world works, right, is basically through these socket-like communication pathways. So the protocol we're using is called TCP, Transmission Control Protocol, and this sits on top of something called IP, which is Internet Protocol. And this networking is arranged in a hierarchy. There's a stack of configurations. I actually get to log in before class. So there's a million pictures like this available, but here's just one. 7 layers of communication. Basically, at the top layer you have applications, web browsers, PuTTY, Minecraft, right? Whatever it is that's trying to do network-based interaction, but from a very high level. Okay, PA5 is going to be sitting at the application level. At the lowest level is the physical layer. This is the Ethernet cable that plugs in, or if you ever use the old BNC, the black coax cables for transferring Ethernet signals, right? Or the wireless communication that's taking place, the sending and receiving of these electromagnetic waves, or the telephone line that's making the beeping sounds, right, and sending information like that, right? So that's a physical layer. And so there's different layers, and the layering helps with this idea that the application layer does not need to know physically how your information is being sent. If I switch from a wireless connection to a wired connection, I don't need to restart my browser, right, or download a different browser, because that's handled by a different part of the system. And my application sees a very standard interface, which is the stuff we're going to be playing with, right? Sockets and data input streams and so on and so forth. And that's shielded from the lower levels, right? Now something needs to respond to the fact that I used to talk wirelessly and now I'm using a wired connection and now I'm using a telephone line and now I'm using infrared, right? But that's handled down here like in the data link layer or the network interface layer. So the TCP layer and the IP layer are fairly high level. And our applications will talk to this TCP layer, and that will talk to the IP layer, and the IP layer talks to levels that are lower. And so there's these RFCs, requests for comments, that that are put out periodically. And this was the RFC for transmission control protocols. So prepared for Defense Advanced Research Projects Agency, that's DARPA, the military version of ARPA. And this is 1981, right? So early days of the internet. And this was basically, you know, a call for ideas and comments and feedback on this transmission protocol. And if you go through this, it's got everything you need to know about TCP, right? Because this was the document that basically, you know, spawned all of this stuff. So here's a picture of the layering, application layer, transmission control, internet control, and the hardware level. And this is a fairly fun browse if you're bored. So it's got good ASCII art, right? So Telnet, FTP, voice, and whatever else could be imagined. There's no web browser up there because web browsers didn't exist, right? But that goes in the ... section. And lots of words and pictures. And this is what gets sent when you make a network communication. You get a TCP packet. And it has 16 bits specifying the port that you're coming from and 16 for the port you're going to. Ports are basically how we identify a socket, right? And then there's sequence numbers, because this is trying to ensure that things arrive, things that arrive out of order get resequenced. Because you send a packet from here to there, and it might go, you know, directly across, or it might go up to a satellite and bounce off somewhere in India and come back, right? And there's different paths that things can take from one place to another. And so you don't know that your packets are going to arrive in information in sequence. So there's information to resequence those. And there's various flags and a checksum, which we use to know if there's an error in any of the transmission. And then there's the actual data, right? And so if I send the letter A, all of this gets sent in front of the letter A, right? Which is a bit of a concern efficiency-wise, because that's a bunch of bytes being sent, right? So each of the little marks is a bit, so 32 bits going across 4 bytes to send one character. So we usually try to bundle up a bunch of characters together and then push them out in one fell swoop, right? So, and this just goes on and on and on, but good ASCII art in different places. There's a nice picture. So there's the flow chart of how connections get established and how they get de-established. Yeah. 1981, what else are you going to do, you know?
Had a lot of free time.
Yeah. So this is RFC 793, okay, Transmission Control Protocol, and look it up sometime when you got some time to kill, right, and start reading through it. And you can actually use this stuff, right? We're going to work with sockets from a high level, but you don't have to. You can go down to assembly language on a PIC processor and make a PIC processor like the ones we use in 270, talk Ethernet. Right? And to do that, you would have to put together these packets, right, and understand what they mean, and then, you know, bundle them together and ship them out through whatever your physical medium is. But you can talk TCP/IP across, you know, anything that you want, basically. Right? I'm waiting for someone to take my little signal flag Lego thing and put TCP/IP on top of it, and that would be fun. So we got this whole picture here of a TCP header, right? And the last part of it is this data packet. So RFC 791 is the IP request for proposals. And that's what an IP packet looks like. And so you don't just get to put a little A in that data part of the TCP packet. The data part of the TCP packet is actually an IP packet. So it's got all of this stuff, right, followed by the actual data. And some more words and more pictures, and on and on and on. So there's a lot of stuff going on, right? And we're not going to have to deal with any of it because we're up at the application layer. But you should know that stuff is there. All right, so we're going to deal with sockets, and sockets basically have two pieces to them: an IP address, which is usually something like, you know, 192.168.2.5, and then a port number, which is usually something between 1024 and 65.535. And so the combination of an IP address and the port number will uniquely identify a socket somewhere in our universe. Okay? The port number will get you to a machine. Sorry, the IP address will get you to a machine. The port number gets you to a particular socket. Every socket has its own port number. So if I create a socket on my machine and you know my IP address and the socket number, you can communicate to that socket from anywhere that has network access. Right, either across the room or across campus or across town or on the other side of the ocean. And our port numbers usually start at 1024 because the first 1024 port numbers are privileged, and you can't create a socket with one of those port numbers unless you have root access. And that's because those are reserved for predefined behaviors. So if you look under /etc/services, you'll see a list of various TCP sockets and what they do. So socket 7, for example, is reserved for an echo. Presumably anything you send to it comes back to you. It's a test port. Socket 13 is for daytime, right, which is, I believe, a clock function. 12 21 is FTP, that's the file transfer protocol. That's how we used to send files from one machine to another. You would make a connection to port 21, and there was a server listening there, and it would listen to your bytes that you sent, and those bytes would form a request to send or receive a file. And so you could do file transfer. 22 is SSH, that's how we do secure communication. So that's the secure version of Telnet. When you use PuTTY and you connect to the server, your port number is set to 22, which means I'm looking to talk to whatever is listening to socket with port number 22. That's the daemon running on the server that's looking for secure connection requests. 23 is the insecure version, that's Telnet. Right, that was when people didn't steal passwords as easily. 25 is the mail program. So simple mail transport protocol, SMTP. That's how you can send mail to someone on a machine. You connect to port 25 and you start a little dialogue with the daemon, and it sends messages. And so on and so forth. So there's a name server, there's a whois server. Finger should be 79, right? So that shows you more detailed information about who's logged in. And then at 80 is HTTP. That's where the web server sits. Now that's the unsecure web server, right? HTTP as opposed to with an S at the end. But if you make a connection to the socket at port 80 on a machine, you're talking to the web server. And you can say, hey, get me this page, please, and it will go into the collection of web pages and look for a page with that name, and if it finds it, it'll read it and send you the information that's contained in there. And that's how your web browser works. So this is what underpins basically all of our networked stuff. And there's port numbers that are reserved for certain games. And I don't know if those will be listed in here or not. And if you've ever tried to do port forwarding to get one of your video games to work, right, this is what it's referring to, is when you get a request for a certain socket, send it to this machine. And this goes on and on. All right, so let's play with some sockets.
Is there one in there called Bacula?
Called what?
Bacula? Like, it's called Bacula.
Yeah, Bacula director. I have no idea what that is. But it's on port 9101. Alright, so I can use Telnet and put in a host name and address and talk to that socket on that server, on that machine, but there's nothing listening on that port right now. So that seems to be dead. And I don't have a mail client running either. I do have a network connection. Alright, so now I'm trying to open an SSH connection to the Linux server, but I don't know how to speak SSH, so it's going to get upset at me. Alright, so there's two kinds of sockets we need to deal with. In Java, there's a socket and there's a server socket. And so we touched briefly on client-server protocol a while ago. So here's a client, here's a server. This is going to have a server socket. And the main feature of a server socket is you create this socket, but it can take connection requests from other entities. So I can create a server socket and I can say accept a connection, and then somebody else can make a socket and say I want to connect to this port on this machine, and if there's a server socket associated with that port number, it'll accept that connection, and now we can start doing communication session. So I want to look at server sockets first. And they're really easy to use, way easier than all of this description we've been doing. You construct it by just giving it a port number. And then there's an accept method, which says listen for a connection to be made to this socket and accept it. And when you accept a connection, it returns an object of type socket. And that's pretty much all we have to do. Most of this other stuff we can ignore. And a socket, the main thing we're going to do with this is get an input stream. So when you have a socket, there's some way to read from it, there's some way to write to it. Okay, the way you read from it is to get an input stream and then read from that input stream. The way you write to it is to get an output stream and write to that output stream. And we can use this input stream to construct a scanner. And we can use our good old scanner object. So let's just try this. So I'm going to import a server socket and a socket. And I'm going to say and so what port number should we use? We've got to stay above 1024, under 65,535. Someone give me a port number.
5,000.
5,000. Say 5,000?
Yep.
Okay. All right, so we're going to use port 5,000. You're going to create a server socket. And I'm just going to print that out and make sure that we got connected. So let's just compile this, make sure our imports and everything work. All right, and so lots of opportunities for exceptions dealing with sockets. So I'm going to do something that I suggested you don't do, which is I'm going to put everything inside a big try-catch block. Alright, so I can run this and it apparently succeeded because it didn't throw an exception. And when I printed out my socket, it had this thing that said local port equals 5,000. So far so good. So let's accept a connection. And let's make a socket. So we'll wait for a connection, and we'll say sock equals server socket dot accept. And then we'll print out got a connection, socket equals, and we'll print out the value of sock. And that's going to be our whole and I'm going to close my socket, and that's going to need to go in a try-catch block also. So I'm going to put it in a separate try-catch. Alright, we got a server socket. It's sitting there, it's hanging out at port 5,000. It's waiting for a connection. Let's say telnet localhost 5000. Localhost is a synonym for my current machine. So is 127.0.0.1. That's what localhost actually maps to. And that's always your local system. So I'm trying to connect to my local machine to port 5000 using telnet, and watch the thing down there that's waiting for a connection. Make the telnet, and it says, hey, I got a connection. The connection came from address 127.0.0.1. That's my local machine, and it came from this port number, which happened to be close to 50,000. And we didn't do anything, right? My server class just exited after it got the connection, which telnet detected, and it said connection closed by foreign host. So there's a cool little utility you should know called netstat. And netstat-a-n, A means show me active connection, N means show me numeric addresses as opposed to names. And if I do this, I get a bunch of output here. Way too much. But this first column that says Unix sometimes says TCP. I'll take my word for it, we'll just grep. Alright, so there's all the TCP connection information, and this last column shows the current state of the connection, and right down here there's a connection that's in the listen state, which means waiting for a connection, and the local address is port 5000. That's the server socket. If I actually make a connection that doesn't close immediately, this will change to established, and it will have the IP address and socket number that the connection is coming from, and the IP address and socket it's going to. So netstat is just a standard Unix tool. There's a ton of Unix tools related to networking. If you've ever done any red team, blue team kind of stuff, you know all these different utilities that are available, right? These all help you with this kind of thing. And there's connections that are already established, right? And I don't know what most of these port numbers are. Maybe I should be worried. Probably not. But you know, if I open up all right, so I'm logged into the Linux server right now, and I do my netstat. Which one of these looks like a Linux server?
All of them?
I don't know off the top of my head. Anyway, one of these is my SSH session. And I made a connection to 22, but then it like got changed with something else. Anyway, you can do this, and then you can break your connection, do it again, and do a difference, and you'll see which one disappeared. Alright, so where are we? Yeah, waiting for a connection. Alright, so let's actually do some communication. So we're going to accept a connection. We're going to say we got a connection. And let's just keep marching forward inside this try-catch block. So let's make a scanner object. So we're going to construct a scanner, and we're going to construct it on this input stream that comes from the socket. So our socket is called sock. So we're going to say sock.get input stream. And that's going to be our argument to our scanner constructor. And let's do our usual scanner loop. So we'll keep reading has next line and printing out next line. And then when we're done, we'll close our scanner, close our socket, and be done. Make sense? Let's see if it works. Gotta import your scanner. Alright, waiting for a connection. Let's open a telnet connection again. Got a connection, and it seems to be stable. So there's our established connection from the same machine to the same machine. This is our client's port number, and our server's port number is still 5000. So let's see if we can get lucky. Hello there. And it says I received hello there. Go. All right, so telnet you can escape with a control right bracket, and there's various things you can do. I'm just going to do a quit to say close out my telnet, and that closed the connection on the socket, and so the has next line came back with false, and I jumped down out of my loop and I closed down the connection, and now everything is like gone away. Alright, so if you have a router, hey, there's a router. So this router has the name CSE223, and it's a highly secure router. So it has a super secret password for 223 called password 223. So I am going to disconnect from Clark Student, and this is going to take a minute because for some reason network changes are slow on my system. But I'm going to connect to that router and rerun my server code, and if you want to go ahead and connect to that router, you should be able to talk to this server using PuTTY or SSH. Alright, so I'm going to connect. And some machines will complain when you try to connect that there's no internet access. And they'll sometimes refuse to connect. They'll sometimes say, do you want to connect anyway? And it's kind of annoying. Because it's like if there's no internet, it doesn't think it's worth connecting to. Exactly. So Ifconfig is another good utility. And in this case, I'm running Ifconfig. So WLP2S0 is the name of my wireless adapter. It's telling me that it's up, and my internet address is 192.168.2.3. So if I run my server code, so first person who can connect to the router and then run PuTTY and make a raw connection to that address, port 5000, should pop up on here. Anybody want to try?
Says I don't have a pin to connect.
There should be an option for saying I just want to enter a regular passkey. That caught me like twice this morning. Let's see who the lucky winner is. So if you run PuTTY, you have to change the connection to be raw, and then specify that as your address, and then in the next window over, specify a port number of 5000. Or if you have telnet, you can telnet that machine space 5000. Hey, got a connection. There we go. All right. So who's that? All right. Good job. All right. Now I can type because it's telnet, right? But there's nothing in my server code right now that's picking up my keystrokes and sending it back. So you're not going to see anything that I send. So it's one-way communication at this point. But it would be a relatively simple matter to run a second thread, right, that reads from my standard in on my keyboard and then writes those things out to the socket, and I can make a print writer off of socket.getOutputStream, and anything I write into there should show up on your telnet window. And there's your basic two-way communication. Yeah?
So what happens if someone else tries to connect as well?
Good question. So right now, if someone else tries to connect, it should say that it should just hang. So let's try telnetting. Oh, that's interesting. That's a feature. So it accepted the connection, but it's not actually. I mean, my code is still down in that loop. But this is a good question. All right, I'm not being rude. I'm going to close out my connection though. So I'm down here in this loop, right? So I can't do anything with the connection. But in general, you create a socket, say address 5000, port 5000 here, and I accept a connection. If I go off and I start running some code, nobody else can use that connection yet. So usually what happens is the following. Say port 5000. Somebody makes a connection request to that. I'll go ahead and say, okay, yes, I will talk to you. You create a new socket, and you start doing two-way communication on that in a separate thread. And your main program goes back and waits to accept another connection. When it gets a connection request, it makes a second socket in a second thread, starts communicating on that, goes back, waits for another connection. And you can put in a counter so you don't get DDoSed. Only accept 5 connections or whatever at a time, right? But then you can have multiple threads talking on their own sockets. So that's a crash course on networking in Java, the basics of server-side sockets. Client-side socket is almost exactly the same, except we're not creating a socket that people are going to connect to. We're creating a socket that we wish to connect to a server socket, right? And so we construct that socket by specifying not just a port number, but also an internet address. So we could specify a host name, or we could specify a 192.168.2.3 kind of address. Second argument of a port number that we want to connect to, and this gives us a socket object. And once we have that, we can do the usual, get an input stream, get an output stream, write to the input, read from the output, and so on. So we'll put together a client-side version of this. We'll play more. Let's play with the server side more first. Okay, let's get two-way communication going on that on Friday after we're done talking PA5, and then we'll start playing with some client-side code. We'll dig into these internet addresses and see how to set those up, as well as finding out things like what's the address of the person that connected to me. And so we'll start building this up. And then we're going to start talking about higher level stuff. We'll look at some of the web stuff for fetching URLs and things like that. All right, good stuff. I'll see you open lab tomorrow. I'll see you there, or Friday.